Hello everyone. In this lecture, we will study about noise figure. So noise figure of an amplifier is given by noise figure is equals to 10 log signal to noise ratio at the input upon signal to noise ratio at the output. It can also be written as 10 log of noise factor f. Okay, if the amplifier doesn't degrade this signal to noise ratio, then the input and output signal to noise ratio remain same. Okay, the noise factor f is 1 and noise factor can also be written as 0 dB. Okay, now what we can write the noise figure as, noise figure can also be written as 10 log of V naught square noise RMS upon 4 kTR B Rin upon Rin plus Rs whole square into A square. Okay, so this is the signal to noise ratio at the input upon output, and when B is small, this bandwidth is small, we measure the spot noise figure, and when this bandwidth is large, we measure the average noise figure. The numerator in this above equation is the total output noise power, and the denominator in this equation is the output noise power due to the source resistance. Okay, so this noise figure can also be written as total output noise power upon output noise power due to source resistance. And if the amplifier is noise free, that is the output contains only thermal noise from the source resistor, then the noise figure is 0 dB. And for low noise amplifier, this noise figure is from zero point 0.5 to 5 dB, and if SNR input is infinite, then noise figure is meaningless. Okay, so noise figure is simply defined as the total output noise power upon output noise power due to source resistances. It basically ranges from zero point 0.5 to 5 dB for low noise amplifier. So this is all about noise figure. In the next lecture, we will study about noise temperatures. Thank you.